record the video and I put the video on tutorial support on your Canvas with the live slide. Every lecture I did today, I put in the slide. It's a tutorial support, it's not a workshop. It means I should start the teaching again. And in the middle of the teaching, I also did I do some example for you guys. Sorry, the class is online. I have some medical problem and hope everything getting better and I come back to the campus and start face-to-face teaching. But till that day, we have an online class. If you have any questions, send an email to me and anything else. I'm not on campus now. I'm just working from home. Hope everything back to normal very soon. Okay. Today we start from calculus 1 that you have the last week is the Maclaurin series. Okay. For the Maclaurin series, for example, if you have this example, 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 and so on is equal to. This series is converges. Why? Because the result is 2. How we can think about this series? For example, if you have these two rectangles, start from the 0, 1, and 2. 1 plus, okay, 1 means this part, 0 to 1. Plus 1 over 2. 1 over 2 is here between this one is the 1 plus 1 over 2 is this part. Add plus this part. And plus 1 over 4. If this one divided it 2 parts, it is the 1 over 4 here. It means that here is 1 plus 1 over 2 plus 1 over 4. Again, add here. 1 over 8, this amount. Here is 1 plus 1 over 2 plus 1 over 4 plus 1 over 8. And keep going. At the end, it decreases. But you reach to 2. It's like the limit, yes? You reach to something. What R really mean? Is 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 2 power, for example, k plus 1 to power n is equal to summation k0 to n number 1 to power k. As you can see here, this is the infinite series because you have an answer for that. It means that note now the finite series summation k equals 0, 1 power k is equal limit n to infinity summation k equals 0 power n to k. It looks like the limit, yes? Limit something. It's very close to get to the 2. And as a infinite series, we can write as infinite series is something of the form of summation k0 ak is equal a0 plus a1 plus a2 plus so on. We say it converges converges to S, and we can write summation of infinity k0 ak would be equal S like this. The summation of some numbers, some series, is equal one exact number. Yes, this is the convergence series. You have an answer for that series. But maybe for some series you don't have any answer and it that exists. For example, this series 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 4 plus something. This series is the number is the very small number, but it doesn't go close to any number. You don't have any limit for this number. You can find any answer for this number. We can say if the summation of some series n k equals 0 ak ak does not exist, then we say the series diverges. Okay. Again, for example, summation k equals 0 to infinity 1 over 2 power k. You know that it converges to the 2. You can say that this series converge to 2. And for example, summation k equal to infinity minus 1 power k. Okay, it looks like what? Is minus 1 power 2 plus, because k starts with 2, minus 1 power 3 plus minus 1 power 4 plus minus 1 power 5 plus 10 is equal to 1 minus 1 plus 1 minus 1 plus 1. Okay, what do you think? Does this series converges or not?
I think it does not converge.
Yes, it's not converges. Okay, if I write this series as this one, like this, Sn equal to summation nk equal to minus 1 power k is equal to. For S2 is 1. For S3 is 1 minus 1 is 0. For S4 is equal to 1 minus 1 plus 1 is equal 1. For S5 is equal to 1 minus 1 plus 1 minus 1 equals 0. It means this series is a 1 if n is even number and 0 if n is odd number. You have to answer. It's not converse series, it's a diverse series, okay? And the other example, for example, this one. What about this series? Series k equal 1 infinity k equal 1 plus 2 plus 3 plus 4. This series is diverges or converges. What do you think?
I think it converges.
This series, if you get a limit from this series, if I write the limit n to the infinity, this series k equal 1 k, if you add they all together, the result is increase to infinity. But infinity is not the converge, it's the diverge. I rewrite this is diverge series because the result goes to infinity. Okay. Okay. Now we want to check how do we figure out if a series converges or diverges. Sometimes for some series that I give you some example, it's easy to find. Yes, some simple series, but some series is not very easy to find. It's a difficult series. Now we want to know how we can figure out that a series is can converge or diverge. Okay, we need the convergence test. We need the convergence test. Okay. First of all, we check divergence test. If AK does tend if AK do not tend to 0, then summation AK must diverge, not should, must diverge. Maybe converge, but must diverge. For example, we can see if you have a small number, for example, 1 plus 1 over 2 plus 1 over 4, a small number, then you have at the end 2 or diverged into one number. But if you have a big number, like this, it goes to the infinity, it's a diverge. But it's not exactly the way you can find. The other test you have geometric series. What's that mean?
Sorry, I just want to ask with the first series. So you said it might reach 2, but why doesn't it reach infinity?
I told you here. Come back here. Because this number decrease and decrease, but this one a small between decreases and included between the 0 2, and at the end limit of the series goes close to the 2. But this number, this one 1 2 3 4, it goes up. If you put in the graph, go up and goes to the infinity.
Okay.
Okay, geometric series, if I write A plus AR plus AR2 plus AR3 plus AR4, and so it means the summation of the K equals 0. ARK, it means the A is the first term or a starting term, then times by R. Yes, times by R. For the is the common Scully's common ratio. This theory means that this theory means that the geometric series infinity K equals 0 ARK is converge if and only if absolute value of the R would be less than 1, would be converges. It means that if absolute value of less than R, then summation of the infinity K equals 0 ARK would be equal to A over 1 minus R. Now, back to that previous example that you have 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 and okay, let's check this one with the geometric. It means that this one is the starting term, then times by 1 over 2, it means the R equal 1 over 2 is the common ratio. It means that the 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 is the equal to A. What is the A? A start number is 1. 1 minus ratio, common ratio is equal to. Okay. Now I think it's clear for you guys why the result for this one would be 2. We can show with the geometric theorem that the test is equal some number with this equation. But for example, for this one, 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 and so on. You know, you have a starting point or a starting term, but there is no common ratio between them. You cannot find any common ratio, and it means you cannot find any geometric test here. Okay, you have a divergence test, you have a geometric series, and now we want to write the ratio test. There is a lot of type of the test for the finding that one series is divergence and convergence, but unfortunately we don't have the one exact solution. You know, you should check with any type of the test that you know to check that series is diverge or converge. You know, we don't have any exact way to solve the equation. For example, you know, the 2 times 2 is 4 is the rule, you can use it, but for example, you have some rules for the limitation or integral or something like that, but you don't have a very stable rules for the solve the diverge or converge. You should test it for everything that you know. And for the ratio test, k equal 1 infinity ak. Now, if L equal limit k close to the infinity ak plus 1 over ak less than 1, then the series converges. If L equal limit k goes infinity ak plus 1 over ak more than 1, then the series diverges, and if L equal to limit k infinity ak plus 1 over ak equal 1, and this point the test is inclusion, in conclusion, and you don't have any answer for this one. You cannot say is it diverge or converge. You cannot say anything. For example, summation k equal 1 and k over 2 power k. If I want to write the answer, is equal to 1 over 2 plus 2 over 2 power 2 plus 3, 2 over power 3 plus so. Okay, now I want to check with the ratio test. Let's apply the ratio test. L equal to limit k goes to the 0, a k plus 1 over a. It would be equal limit k to the 0, k plus 1 over 2 power k plus 1, k to power k. Okay, it means that the equal limit k's go to the infinity in absolute value, k plus 1 over 2k plus 1 times 2 power k over k. Okay, I can write here like this, limit k plus 1 over k times 2 power k, and I can write 2 power k plus 1, 2k times 2, yes, and I can cancel this too, and this one would be equal to limit k to infinity, absolute value k plus 1 over 2k. Now, if I let me copy this one, go to other page. All parts. Oh my God. Okay. If I cut it here and put it here. Okay. Now I can take it out 1 over 2 from the limit k to infinity, k plus 1 over k. I can write this one 1 over 2 limit k to infinity, k divided by k1, 1 plus 1 over k. Okay, limit to the infinity. This one goes to the 0, yes? 0 plus 1 is 1, and limit after 1 is 1 over 2, 1 plus 0 is equal 1 over 2. You can see this one is less than 1. When is less than 1, this series is converges. Yes, I can write here that this series converges. The series converges. Okay. Could you please, you guys, check this series, the other example? I just write this, the name of this series is the harmonic series. Test it with this series is k equal 1 over k, and try the ratio test. What's that the ratio test means? It means L equal the limit k to infinity a over k plus 1 over ak. Could you please do this one? Do you find any answer?
Divergence. This goes to infinity.
Okay, let's do together. Okay, this one is equal to limit k to infinity. This one would be 1 over k plus 1 over 1 over k. That would be equal limit k to infinity. And you know the rules, far and close, k in the up, k plus 1. Now this one I can write limit k infinity divided by k, every symbol k by k, k divided by k plus 1 divided by k, it would be equal limit k to infinity 1 over 1 plus 1 over k. If you use the limitation 1 over infinity is goes to the 0, it would be equal 1. It means that look at here, this ratio in conclusion and conclusive, sorry, it means the ratio test is inconclusive and you cannot say it diverges or diverges. The other test that you have is for the power series. What is the power series? Summation k0 to infinity ck, and you have now one variable here xk. It's look like that. C0 x power 0 is 1 plus c1x plus c2x2 plus c3x3 and plus this. If this converges for some value of x, then it define a function of x. F of x is equal to summation k0 ck xk. For example, f of x is equal to summation k equals 0 infinity xk. It means now here c is equal 1 or ck is equal 1 because we don't have any number here. Yes, c is equal 1. Okay, we check this one. This happen to be a geometric series. What's that mean? A is equal 1 or equal x. And do you remember the geometric series? Common ratio and the starting the point. Now let's check. It means that if x now is the common ratio, yes, less than 1, then the series converge to f of x is equal 1 over 1 minus x. And if absolute value of the x more than equal 1, then the series diverges and doesn't define a function. You can see if you plot this graph with computer or with your hand and anything that you are familiar with that, the power for this point, let me show you. This one, if I show you here -1 and 1, here is 1 and y equal f of x here. Look at see here. If the result less than or equal 1 or less than 1, sorry, not equal. It means open these two sides. Between these two, we can see have the series converge. But more than equal 1, this part or this part, this series is divergent and we don't have any answer for the converge or divergence series. Okay. It means any time you should check the test. Which test is geometric test, check the ratio test and see which test is the give you the answer for this solution. Okay, you should check it. Okay, if let me stay quicker, I want to cover last week for you guys, Maclaurin series and the Taylor series. Let's see visit some this series. Let's check this series. Okay, if f of x is equal to summation k equals 0 to infinity xk power over k factorials. It one would be equal to x power 0 is 1. 1 factorial is 1 plus x power 1 over 1 factorial again is 2 plus x power 2 over 2 factorials and plus x3 over 3 factorials and so on. And we saw if this converges for this series converges or diverges. Let's check. We can say as a exponential function. We can write e power x is equal to summation k equals 0 x k over k factorial. We should use this rule. And now let's check the derivative. D over dx e power x, is e power x, and e power 0 is 1. And as you can see here, if I write here f0 you have a 1 plus 0 plus z power 2 over 2 factorial plus 0 power 3 over 3 factorial plus 1 is equal 1, and derivative of f of x is equal to derivative of 1 plus x plus x2 over 2 factorial plus x3 plus 3 factorial plus so that would be equal to derivative of the 1 is 0 plus 1 plus 2x over 2 factorial plus 3x2 over 3 factorial plus 4x3 over 4 factorial plus sum. If I try to copy this one and cut and paste it here, as you can see now, it would be equal to 0 plus 1 plus, I can write 2x 2 times 1 factorial plus 3x2, I can write 3 times 2 factorial plus 4x3 4 times 3 factorial, and this 2 by this 2, this 3 by this 3, and this 4 cancel. Again, you have a 1 plus x plus x2 over 2 factorial plus x3 over 3 factorial. As you can see, again, this function repeat, yes? Just for the 0, give you 1, and for the other function, give you exactly repeat the factorial. If you get the second derivative or fourth derivative, again give you the same function. And we can say, because you have it 1 and e power x, you have to resolve for this function. We say this function is the diverge function, it's not the converge function. Okay, this is for the power series. Now we can say representing functions as power series is very useful, but how can obtain such series? You know, I write this function, but how can check this one is equal e power x is equal this function? How can we can obtain such a this series? Okay, first of all, suppose f of x has a power series expansion. You can write f of x is equal c0 c1x c2x2 plus c3 x3 and so on. Now, how do we find the values of C0, C1, C2, and so. What do you think? How we can find the values? Do you have any idea? How we can find C0? Yanto, do you want to say something? What do you think? What is your idea? Just say something. It's okay.
Differentiate.
Yes, exactly. But for the C0, first of all, if I put F0, you have a C0 plus C10 plus C20 plus C2 times is equal C plus blah, blah, blah. Plus blah, blah, equal C0. It means that you can find C0 first term, starting term, by put the F0. But now for the rest of them, to find, let's write here, we find C0 by plugging in x equals 0. And now we find C1. We use the differentiation and use differentiation and then plug in x equals 0. What's that mean? I can write here f prime x is equal to c differentiation of the d over dx c0 plus c1x plus c2x2 plus c3x3 and so on is equal to 0 plus c1 plus 2 c2x plus 3 c3x2 plus 1. And now if I put f prime 0, then you find c1 because all items goes 0. Now again, same for the find. To find C2, you can use the differentiate twice. Now f double prime x is equal d over dx. Now c1 plus 2c2x plus 3c2x2 plus 1 would be equal to 0 plus 2c2 plus c3x plus 1, and again put the f double prime second derivative 0, then you have a 0 plus 2c2 plus 0, and you can find C2. It means for the put F0, you can find C0. If first differentiate, you find the C1. Second differentiate, you can find C2. Third one, you can find C3. And goes Fn, it look like n factorials Cn. This is the Maclaurin series. It means the Maclaurin series for f of x would be equal to f of x plus, f of x equal f0 plus f prime 0x plus f double prime 0 2 factorials x 2 till n. It means if I write here C0 is equal F0, C1 is equal F prime 0, C2 is equal to 1 over 2 factorial F double 0, and C3 is equal to 1 over 3 factorial F 0, and Cn is equal to 1 over n factorials f n 0, and I put them here. Okay, let's do this for the example for the f of x. Let's do this one for this. Like f of x is equal cosine x. F prime x is equal minus sine x. F double prime x is equal to minus cosine x. You joined to the class very late. Just come a bit. Okay. F triple x is equal sine x. F 4x is equal cosine x, and look at here again, same like this one, look like repeated. Now f0 is equal cosine 0 is equal 1. F prime 0 is minus sine 0 is equal 0. F double prime 0 is equal minus cosine 0 is equal minus 1. F3 0 is equal sine 0 is 0, and again F4 derivative 0 is equal to cosine 0 is equal 1. Now from the Maclaurin series, I can write cosine x is equal to F0 plus F prime 0x plus F prime 0 2 factorial x2 plus F 3 prime 0 x 3 3 factorials and so on. It would be equal to 1 plus 0 plus minus 1 over 2 x2 plus 0 plus, if I write 4 here as well, 4, let me write 4 here for you guys as well, plus f4 0 4 factorial x4 plus would be equal to 1 over 4 factorial x4, and I can write this one as a 1 over minus 1 over 2 factorial x2 plus 1 over 4 factorial x4 and minus, if you keep going, x6 6 factorial plus x8 8 factorial minus x10 and goes on. Now you had before if, let me show you, e power x, you have it before e power x equal 1 plus x2 over 2 factorial. I use this one. I write here. We recall e power x, that would be equal to 1 plus x plus x2 over 2 factorial plus x3 over 3 factorial plus x4 over 4 factorial, and let's plug in x equal I theta. E I theta is equal 1 plus I theta plus I theta power 2 over 2 factorial, sorry, should be out of I theta power 2 factorial plus I theta power 3 factorials plus I theta power 4 factorial plus, so now I can write this one equal 1 plus I theta plus, okay, you know that from the complex number I square is equal minus 1, yes, I square is equal minus 1 from the complex number, you know that one. And now I square theta is minus theta 2 over 2 square plus, and for the I3 you can write just I and let me one step back, maybe give you best view. I can write this one 1 plus I theta, you know that is the complex number. We can delete it here, I here, because the power is 1, power 3, power 5. It doesn't mean here, but I square is minus theta 2 factorials Again, this one I power 3. You can ignore this one. Plus I4 is plus theta 4 factorial minus theta 6 factorial and plus till n. And you can write here as a, now this part is the first part and the second part plus I. Now theta plus my theta 3 over 3 factorial plus theta 5 over 5 factorial. You can see we've divided the odd and even powers separately. You know that the I square is equal minus 1. But I power 2 you can write as I square times I. For example, I factorize I here, remain I square inside, yes, and is minus 1. Or I can write I5 as I4 times I, and I4 is minus, let me write for you here. Minus time of minus time is plus, and the I is outside the bracket. It means I can write EI theta as equal to, we can see here this one. 1 minus theta 2 over 2I is completely similar like this. You have a x, you have a theta here. We can write as a cosine theta and plus this one is sine theta. If you check with the sine, you find that this one as a sine theta. I sine theta. And now if you plug theta to pi, EI power pi equal cosine pi plus I sine pi, and would be equal to minus 1 plus I 0. It means that I pi is plus 1 is equal 0. You can use this formula anywhere that you want. You can use this formula as a cosine x, or this formula as a sine theta, or this formula as a cosine theta. Is the officially the world's most important formula, and at the end you have a EI pi plus 0 plus 1 is equal 0. Okay. You have the other method to find the to obtain the power series with the, so I write some of them for you here. For example, 1 over in your, let me say which page in your notebook. The first page, if you see the Taylor series in the first page, you have some type of the series that you can use it for the power series for the Maclaurin series. For example, 1 over 1 minus x is equal to summation infinity k equals 0, x power k is equal 1 plus x plus x2 plus x3 and plus continuous. Okay, now and you have the list of this series that you can use it. You can see a power x here, you can see sine x here, cosine x here. I explained for you how we can find a power x, sine x, cosine. Now you can use this series to find your answer in the other series. Now we suppose we want a power series for f of x equal x2 plus x. Now look how we can use those mentioned series to solve this equation. Okay. Sorry. I should change my position. Okay. We can get this but we should manipulating the known series. Okay, what series that you have? I want to use this series. 1 over 1 minus x is equal to 1 plus x power 2 plus x power 3 and so on. Okay. Now, if I times by x, it would be equal x over 1 minus x times 1 plus x plus x2 plus x3 and so on. Now, if times by x, now divided by 2. I have here x power 2 1 minus x is equal to x over 2 1 plus x cube x square plus x cube and so on. Now we can see this function is x over 2 plus x2. Okay. Now for this one, I want to plug. Let me put this one here. I want to plug in minus 1 over 2 x2 into x. You can see if I write x over 2 1 over 1 minus 1 over 2x. It means that now you don't have x, you have a 1 minus over 2x. This one would be equal x over 2 plus x2. The same function that you have. Now, I want to using 1 over minus anything can be here. Would be equal to 3. You can put everything instead of the square. I can write this one x2 plus x2. I can write as a 1 plus. Now, what should I put instead of this one? Minus 1 over 2 x2 plus minus 1 over 2 x2 power 2 plus minus 1 over 2 x2 power 3 and so on. It means that from this part, let me write this one here is better. Right, 1 minus 1 over 2x2. This one is equal by this. Now x over 2 plus x2 is equal to x power 2 from here times by this bracket 1 minus 1 over 2x2 plus minus 1 over 2x2 power 2. So this would be equal to x over 2 minus x3 over 4 plus x 5 over 8 and so on. It means if I write in the summary you know that the 1 over 1 minus x is equal 1 plus x plus x2 plus x3. So I can write here 1 over minus 1 over 2 x2 would be equal to 1 plus 1 over 2 x2. It would be equal to 1 plus minus 1 over 2 x2 plus minus 1 over 2 x2 power 2 plus so. And if I write x2 plus x2 is equal x over 2 times 1 plus 1 over 2 x2, it would be x2 times by 1 minus 1 over 2 x2 plus 1 over 4 x4 minus 1 over 8 x6 and so on. That would be equal to x over 2 minus x3 over 4 plus x5 over 8 minus x7 over 16 and so on. You know, I use the one series to find the answer for another series. Okay. Now, one more thing I should mention here, and I think it would be the last one. a Maclaurin series for a function f of x gives us good approximation to f of x for values of x close to 0. It means f of x is equal c0 plus c1x plus c2x2 plus c3x3 and so on. It means c plus, let me write here, cn fn 0 and you know that the cn is equal fn 0 over n factorial. It means the degree n Maclaurin polynomial is Tn equal so Tn times f of x is equal c0 plus c1x plus something plus cnx n. For example, t3 sine x is equal to x minus x3 over 6, or t2 cosine x is 1 minus x2 over 2. We can put some polynomial function. Okay. To get good approximation to f of x for x near a, we use Taylor series. We use the Taylor series. What's that Taylor series? The Taylor series of f of x centered of x equal 0. Now is, I better write a here. Now is f of x is equal c0 plus c1x minus a plus c2x minus a power 2 and so on. It means that the fa is c0, f prime a c1, f double prime a 2c2, and f power n a would be n factorial c. Again, it's same, and you can write for the Taylors. For the Taylor series, we can write fx is equal to fa plus f prime a over 1 factorial x minus a plus f prime a 2 factorial x minus a power 2 plus f a 2 factorial x minus a power 3 and so on. For example, the Taylor series for f of x equals sine x, center of a equal pi over. Let's see what should it. You know that f of x equal sine x, f prime x is equal cosine x, f double prime x minus sine x, and triple x is equal minus cosine x. And if you check here, it means f pi over 4 fa is equal to a square root of 2 over 2, or equal 1 over a square root of 2, and f prime pi over 4 is 1 over a square root of 2, f double prime pi over 4 minus 1 over a square root of 2, minus 1 over a square root of 2. Now, if I use the Taylor series, it means that sine x is equal to f pi over 4 plus f prime pi over 4 over 1 factorial x minus pi over 4 plus f double prime pi over 4 2 factorial x minus pi over 4 power 2 plus f double prime pi over 4 3 factorial x minus pi over 4 power 3 and so on. It would be equal to 1 over a square root of 2 plus 1 over a square root of 2 x minus pi over 4 plus, now is minus 1 over 2 square root of 2 x minus pi over 4 power 4 minus 1 over 6 square root of 2 x minus pi over 4 power, should be here 2, sorry, power 2, and so this is the Taylor series. Now I can write here for the in general for the power series with the center. Yeah. In general, a power series centered at x equal a is a series of the form S equal to summation infinity k equals 0 ck x minus a power k. We can write c0 plus c1 x minus a plus c2 x minus a power 2 and so on. And converges of our series would be then exists a radius of convergence R for S converge when x equals 0, S converge for x minus a less than R, and S diverge for x minus a more than R. It means that if I show you a diagram here, you have a here, a minus R here, a plus R here. In this part, between these two, you see the converge. Out of these two parts is S diverge for the power series. I think it's enough today. We will continue next session as well with one more example for this part and also new topics. Do you have any questions?
No.
Okay, I record everything. I put in the Canvas in the tutorial support, and also this you don't need to write anything. I put live slide in the Canvas as well. You can see everything. If you have any question, just send an email to me again. I will see you next week. We should keep going by Zoom till I feel better. When I feel better, I will back to the uni. Okay. Thank you for your attending to the class. See you next session. Have a good weekend, guys.
Thank you.
Bye-bye.
Bye.